In order to analyze kinetic energy, we'll look at a very simple problem. For example, number 1, we have a 7 kilogram object traveling at 3 meters per second, and we simply want to know what that object's kinetic energy is. So much like we've done in the past, we're going to list everything we know. We know it's a 7 kilogram mass traveling at 3 meters per second. And all I need to do is plug everything into my equation. Since the kinetic energy is 1/2 mv squared, 1/2 times the mass of 7 times the velocity, squaring only the velocity, I should find that this object has 31.5 joules of kinetic energy associated with its motion through space. That's probably your most straightforward example. So we'll change it up a little bit for example number 2. And we'll see. We have an 8 kilogram ball and it is traveling at some unknown velocity. And we are told that its kinetic energy, its total kinetic energy associated with that motion is 150 joules. And the question would be, how fast is that mass moving? Just like we did before, we're going to list everything that we know. 8 kilograms of mass, unknown velocity, 150 joules in total of kinetic energy. So the kinetic energy equation, 1/2 mv squared. We plug in the 150 joules for our energy, 8 for our mass, and the only thing that's unknown is our velocity. So if we solve that through to the next step, we know that 150 equals 4v squared. Therefore, dividing both sides by 4, I will find that the square of the velocity is 37.5. So I must therefore take the square root of 37.5 to find that this object must be traveling at 6.12 meters per second. Outside of that, kinetic energy calculations are as straightforward as they seem. It's when we move on to things such as the conservation of energy in which things will become a little bit tricky.